Good afternoon. Thanks for coming. We're going to start with a test. We're going to start with a test about perception. And we want to know if you can perceive a state change. And the state change is going to be conveyed to you through music. And I'm going to play one of the clips that you created, Chris. Do you want to introduce it briefly? Do you want to say anything about it?
Well, to introduce it would be to give away what your test is.
So we're just going to listen to it.
Sure.
So no introduction.
Yeah.
So it's going to take a minute, and I'm going to ask you to tell me where the state change is in this sound. Okay, where was the state change?
Several.
Okay.
16, 27, 50,
Okay.
and a couple more.
And then there's a massive one at the very end, right? You noticed that. Everything sort of hums along, goes and there's a few changes in there, but there's one really massive one at the very end. Now, Chris, for the reveal, what have we been listening to?
So this is a kind of a mashup of various data sets from ice cores in Antarctica, and there's deuterium kind of humming along the lower, fuzzier sound, and then the carbon dioxide is the little higher, more whistly thing about an octave higher. And your multiple state changes, those are actually the interglacial periods along 800,000 years of the data record in this thing. Deuterium, because it's a proxy for temperature and gives us, a good trace of something that by ear and by eye you can see very correlated, with the carbon dioxide level. So.
Thank you. So if you feel a lot older after listening to this, it's because you just listened to 800,000 years worth of data compressed into 1 minute. And that's one of the fundamental challenges of climate change, is that temporally it is a very complex thing to perceive in terms of cause and effect, because we're used to perceiving causes and effects within a range of maybe a minute, an hour, a week. But after that, our cause and effect correlations sort of break down because we can't remember what happened a week ago so clearly, unless it's really traumatic. And but here we're dealing with effects that we have to understand in the context of 800,000 years, so way beyond the experience of a lifetime. And that's a huge challenge. So let's deal with these challenges a little bit and look at what kinds of methods we might have to understand climate change better. What I did as an artist is I actually chose to travel to a ground zero of climate change, and that ground zero is Barrow, Alaska. And just to introduce Barrow, Alaska, I'm going to show this picture. This is what I saw when I got off the airplane. Barrow, Alaska is the northernmost point of the United States, and I expected to see, not penguins because that's Antarctica, but I expected to see, beautiful icebergs and maybe a few eider ducks flying by. And what I actually ended up seeing was an ice field. This is Arctic ice. This is in June. It's very cold. It's like freezing, of course. And I expected it to be much more pristine, but it really wasn't. It was dirty. It was full of trash. It was melting. It was not looking as pristine as I thought it was, and yet it was full of a very profound mood of a certain kind of realism that I was very impressed with. So I'm going to show a few travel pictures, and as I do, I'm going to pass around two artifacts that I want to share with you. This is a piece of baleen from a whale, from a bowhead whale, that is been carved by local Native American artists into a decorative item with 3 polar bears and some melting ice around it. So I'm going to pass that one around. And Another important thing about Barrow is that there's a huge scientific research reserve that is managed by the people of Barrow, by and this for the benefit of scientists. And it is separated by these markers. They've been replaced, so I was able to take this one along. It's separated by these markers from the Native American hunting grounds, which is very important because you don't want to get science and hunting mixed up. And so these, I'm going to pass this around if you actually want to smell it. It still smells like the tundra. It smells like this peaty kind of tundra, so you can pass that around as well. That's just so we have tangible evidence here that we actually saw this place. And there's a third component which I'm going to pass around, and then we have everything set up. And the third component is created by Christine Zhang and Akila Raja, who's right here. And they are going to show a VR implementation of several pictures from the Arctic trip, and you can put this on your headset and explore it. There's a button on the side. You can tap the button to get from one sphere to another sphere, and I'm very interested in seeing how you enjoy this experience. And so let's go onwards here. And the first point I want to make is that climate change is not a thing. Climate change, as Bruno Latour, the philosopher, described, thing is something that we all agree on. Thing is something we can pin down. And here we have a literal example of a dragonfly being pinned down to explain this concept. It's from the Essig Museum of Entomology in Berkeley. And so once something is pinned down, we can sort of all agree to what it is, and then it becomes a thing. But climate change is much larger than us, and it certainly doesn't want to be pinned down. So therefore, we can't quite agree on it. And it doesn't become a thing, it's something else. And you could say that it's kind of like, this is a very dark thought, but it's kind of like death itself. Death, when it doesn't happen, it doesn't exist. And when it does happen, we don't exist. And climate change is the same way. When it doesn't happen, we really don't care much about it. We don't feel it. But when it does happen, then our existence is put into jeopardy. So it's not a thing, it's something else. And it's something that's very hard to communicate and to mediate, and let's explore what else we can do with it. So just looking at Barrow, this is the top of the world. It's a monument that has been in, not in great shape. It's been weather beaten, but it's used to say, welcome to the top of the world, the northernmost point of the United States. So I'm talking here about US territory, and what's happening in the US territory up here is that the soil is melting away. The permafrost is no longer frozen, and it's melting away fairly rapidly, much more rapidly than scientists expected. And one of the reasons I went up there is to actually experience this, because reading about it is one thing, but walking on soft permafrost is a whole different experience. And we'll get into that more rapidly. But the person that guided me through this is Margaret Thorne, and she's a professor of climate science and soil science at LB, Lawrence Berkeley National Labs, and Chris's daughter, Ori Chafe, who happened to be working with Margaret Thorne. So we'll meet all these people as we go along here. So when you freeze something for 3,000 years, that means the plant matter contained in the soil is a solid, frozen solid. That means microbes can't get to it. And it just sits there, and microbes have nothing to eat. So there is no production of methane, and there's no production of carbon dioxide. However, this has recently changed very dramatically in that same fashion that we heard when the sound went up at the very end of the sample. So you have to imagine permafrost as a massive layer of soil that has not been decomposed, where the plant matter has not been decomposed for 3,000 years. And now, because it's melting, microbes are having a field day, eating tons of surplus material, and are really productive, and they're releasing carbon dioxide and methane like they've never done before in the summer season. And this is what it looks like. So this is a single methane bubble in Barrow, Alaska in June 2016. So the tundra is a lot of wetland, and it's a very marshy, very swampy, but there's grass that comes out, and every blade of grass has bubbles percolating around it. And these are either CO2 or methane bubbles, and they have a very significant impact on the global warming because they're an additional production of greenhouse gases that is accelerating dramatically and exponentially. But to illustrate the problem, we're really not worried about this one bubble. What we're worried about is this. And I'm not sure if this, I think this has no sound at all, so we can talk over it. Here we have a wind-proof drone. There's a lot of wind up there, 30 miles per hour. Can we lower the lights a little bit so we can get the image more clearly, Lance? Thank you, Lance. Yeah, so here we're flying a drone. There's a professional pilot controlling it. Actually, it's an algorithm that he programmed, but still. And we're flying towards, in this, you got the marker that you pass around. Who has the marker? You have it. Does it smell like tundra? You get it? The tundra smell? A little bit? Yeah? Okay, well, within that research area marked by that marker, you can fly drones and do research. And here's a bunch of installations. On the left, you see a tram that goes back and forth and samples soil and air quality throughout the warmer season, and looks at how much snow melts and things like how fast snow melts and things like that. And then in the middle there, what we're flying towards is a eddy flux station that measures the flow of gases from the air into the soil and from the soil into the air. And this is a research project, a national research project funded by the Department of Energy, which is very interested in global climate change, but apparently in the next administration this is going to change. So it's an interesting topic. All these eddy flux stations might be defunded soon if we're not careful. Anyways, we're flying right up to this drone, this sensor here, and I hope we're not going to run into it. Careful, careful now, careful now. Okay, close call. And we're going to go up 400 feet here, and this is just to illustrate what the tundra looks like. So it's not a single blade of grass we're talking about. We're talking about a massive emanation of gases across a huge, huge area. What you see is these strange melting patterns. They're called, there's many terms for them. The melting patterns produce polygons, and the polygons have ice wedges around them that keep the polygons, they contract and expand, and these polygon shapes produce, and the contractions and expansions produce these strange polygon shapes. And they're, so you sometimes have a soft melted part right next to a hard part, and actually there's a particularly interesting formation called the ice lens. Still going on. And so sometimes you have soil that is melted on top and soil that is melted on the bottom, and then you have a big piece of ice in the middle. And so there's really complex shapes that emerge. This looks like a different planet, doesn't it? It's so amazingly foreign. You see some pieces of ice that are underwater, so because the ice is not floating up, it's tied to the ground, and there's water above the ice and water below the ice, and then the ice lenses sit in there in these ponds. We keep going. Now we're getting a lot of wind up here, so if you heard the audio, it would be like because there's nothing stopping the wind. This is called the North Slope. And as far as the eye can see, there is nothing but tundra. These little trails are trails that people walk on to get to their research installations, because you can't drive there because it would disrupt the scientific nature of the preserve. Sometimes people do drive and they leave these tracks behind, and the tracks are there for hundreds of years. They don't go away because then there's nothing that changes them. Well. And then here's the view of the horizon, and as you can see, this flat land does not end until we run out of horizon. So how much tundra is there? How much permafrost is melting right now? And here we're looking due north right now. This is straight to the North Pole. North Pole is about 1,000 miles away from here. Here, the propeller of the drone. Okay. So that's the full 360. And There's not a town, not a mountain, nothing in sight. Okay. And so the question was, how much permafrost land is there? 8.8 million square miles. So this is a gigantic process that is beginning, and I don't think anybody knows how to stop it. So it is very, very, very scary. But we are observing it very closely, and one of the reasons why we know so much about this region is because NOAA has been up in Barrow since 1971, and they've been studying CO2 up there and temperature. And so the very last piece of Chris's music that you heard before is produced by this this kind of data collection up here, where we could see the correlation between CO2 and temperature change since 1970. It's called the Keeling curve, after the scientist who discovered it. The air quality gets studied here in this observatory, and it's quite beautiful because it's all so spontaneously built. Everything is kind of improvised. So I'm going to go over here. I'm going to introduce you to Lieutenant Diane Perry, who sits up there on this tower, and you have to climb up on this thing every day to maintain it. And imagine doing that in high winds and so forth. And there's no rails, nothing. You just have to sort of get up there safely and get back down again. And this is one of the images that's in the VR device. Who has the VR device right now? It's over there. And I want to mention to you that if you tap on the side, you get from one bubble to the other. And we're very proud of this. This is our media innovation that actually works. So the challenge is, how do you get from one VR picture to another? Because they're always so enclosed, and there's no page to turn, really, right? And so we thought that maybe if we just rise through the bubbles, we get a nice experience of transitioning from one space to another, and that actually works. And so you can try that out just by tapping on the side. Is that correct? Is that the correct instruction? Okay, good. Thank you. All right, let's explore this region a little bit further. The Keeling curve, 1971, the average was at 331 parts per million, and today, at that time, the ground was frozen solid. I'm going to show you something very unique here, which is the inside of an ice cellar. So if you have permafrost and you need to hold on to food, you can simply dig into the ground and you have a deep freezer. And it stays rock solid frozen for the entire year. And so you can see the ice crystals on the side of the wall. You see the ladder goes down. The ladder is very, very slippery because it's covered with blood from people carrying meat up and down. And it's a little hairy that way, but you see a single light illuminates the whole thing, and if we come around here, and if we look below a little bit, we can see pieces of whale meat being stored on the soil, and you see me trying to take pictures without stepping on the whale meat, which would have been very rude, I was told. And that's the cave, that's what it looks like. And this is really quite amazing. You touch the walls, it's totally cold. And then here's a hatch, and of course, they were joking, we're going to close the hatch and let you feel what an ice cellar is really like, but I did get out, I guess. Today, the Keeling curve indicates that we're at 407.58 parts per million on average in December of 2015, which is far more and which really produces all these dramatic effects. So let's continue on the trail of the whale meat here and look how the whale, this is the house on top of the ice cellar. And this is in Barrow, a very elegant home because it has a big ice cellar that's clean and because it's well insulated. This is about an $800,000 home in Barrow. And here are members of the Edwardsen clan, and they're all checking out the loading of the whale meat. They're preparing for a celebration where they're going to share this whale meat with the whole community. And it gets put in the truck, and here's the hotel, not the hotel I stayed in, the Arctic Hotel. There's one of the two hotels there. And so the whale meat goes off and it gets shared in a family dinner here, again at the Edwardsen home. And so the big chunks of whale meat get sliced into these little bits, and these little bits are very chewy and you can eat them. They have very high protein, they're extremely nourishing, and a lot of fat too. And what they do is they preserve it by putting it into the blood of whale blood, and somehow there's a fermentation process in the whale blood, and the whale meat comes together, and it becomes softer and more easy to chew. And this is the traditional ulu knife that they use to cut the meat into little bits. And going on here, these houses are very much clan houses, and this is a bit of a funny picture that's loading here. It has after the lunch that we had there with the whale meat, we had a gentleman guarding the house, and I think that this situation here where he's looking out of the house and he's checking out what's going on. There's some people out there guarding the house as well, or just looking out and seeing what's happening. And the juxtaposition of the sewing machine and the marine shotgun is very descriptive of the Native American lifestyle. It's a subsistence lifestyle in this case, where sewing is important to keep, to build your boats with sealskin and so forth, and to make your clothes and to fix things, because you're very far away. There's no roads that lead to Barrow. You're completely isolated. And then, of course, the daily practice of hunting, which is where a large part of the diet comes from. I think up to 90% of the diet comes from hunting. And then on the backyard here, this view here. And there's a different kind of looking out that the scientists produce, and it's even more contained. This is the inside of the lab where where we saw the tower earlier, the NOAA observatory, where the gas samples come in and they get analyzed and stored. And this is the very heart of it, where the tubes bring the gas to the sensor. This building's been around for a very long time, so you see generations of scientific equipment piled on top of each other. Look around here. Here are all the Teflon pipes, reference gas containers to calibrate the equipment. And so this brings us to this observation that climate change is really not something that can be communicated in a simple way. And what I'm mostly concerned with right now is how many people seem to think climate change is not a problem at all, and some people think it is a problem, and some people think of it, make a lot of measurements, and write a lot of papers about it, and articulate it with a lot of detail, but still we're not really communicating about the problem. And so the metaphor of comparing climate change to death works here as well, because everybody has a specific and individual idea of what death is like. And we respect that about each other in most cases, and say, oh, that's how you imagine it, that's how I imagine it, because we know that none of us have a complete understanding of what that means. And so my reframing of climate change conceptually would be to say that we admit that we have no idea what's really going on entirely, that all our renderings are incomplete. And if all our renderings of this idea, all our mediations around this idea are incomplete, then we can start listening to other people's incomplete notions of climate change and consider them as such. And the hope is that if we put it all together, we get a clearer picture, but it's still incomplete. But definitely we can't afford to discard any of the responses. And so one of the mysteries for me in Barrow was that all of the Native Americans I spoke to were Trump voters. And they had posters for Trump on their houses. And I actually had this strange experience where I was taking pictures of their houses, and I looked at the pictures later on, and I saw the Trump poster in one corner of an image, and then I took another picture, and I saw the Trump poster in another corner of the image, but I could not get myself to take a picture of that poster because it didn't mesh with my idea of what Native Americans should think about climate change. And so it was my bias that prevented me from actually seeing what's going on. And I thought that was a fascinating failure, and in a way an inspiration for all this other work, and for taking a closer look at what we don't pay attention to. And so in order to understand climate change, we really need a medium that gets us to look at what we don't want to see. And the situation in Barrow is, we'll see more pictures, is that the soil is literally washing away from under the feet of the inhabitants, and that's a tremendous challenge. So one way to pay attention leads to another sonification, and I'm going to play this, but you want to say something about it beforehand, right?
Oh, okay, yeah, why don't I? So my daughter Ori's been going up there for 3 or 4 years. She works for Lawrence Berkeley Lab and is a field biologist. She is running a number of experiments which are basically gathering data, very, very kind of hands-on with the permafrost, if you can imagine that. So you saw that tram from the drone shot. It was a kind of long, straight line. And I just called Ori about an hour ago and said, how long is that tram? I've never been up there. She says, about 65 meters. So that gives you a sense of how long that extent is. And the very first summer she went up there, she sent me back some data that she said, hey, here's some more fodder for your crazy sonification experiments. See what you want to do with this. And you'll hear it in a sec. It's kind of revealing. I just got another sort of explanation from her to refresh my memory of what that data is. Well, it's that location exactly where the tram is. And she spent an afternoon, which became the first of 3 summers worth of afternoons, where she hauls a bunch of equipment out there. And she's measuring the release of these trace gases from the permafrost, right? So the way you do that, and this is the methodology of the experiment, this very particular experiment that she's involved with, it's high summer, the plants are photosynthesizing like crazy, so they're giving off these gases as well as the permafrost, which is implicated in releasing it as well. So how do you distinguish from permafrost versus the plants that are on the surface? And the way you do it in her method is chambers. And I think we had a shot of the chambers. I can't remember. But
in the VR version, there's a
Yeah.
shot of the chambers with gas coming out in the animation.
Yeah.
So if you get to that, you know what it is.
So she packs these things out to the site, and she has a opaque chamber and a transparent chamber that she puts down over the ground, and there's a gas analyzer inside that's measuring methane and carbon dioxide. So the difference between the one that's open and the one that's opaque gives you the difference between day and night. And plants which are alive and photosynthesizing actually respond to light in that way, obviously. Whereas the permafrost itself is not light sensitive. And so looking at, say, 5 minutes of readings from the open chamber, the light, the one that's open to light.
The day one?
Yeah, it gives you a particular rising slope of the gases being trapped in that chamber. Then you do the same thing with the black one, and you get a very different slope. The difference in slopes indicates the contribution from the permafrost. It's a way of eliminating the contribution from the plants, if that makes sense, hopefully. So what you're going to hear is actually just a kind of tune with a rhythm to it, where her whole afternoon is compressed into, I don't know how long this lasts, couple minutes. 3 minutes. And the rhythm is light chamber, dark chamber. Pack up your gear, move 3 yards. Light chamber, dark chamber. And what you're going to hear is the actual rise of the CO2 and the methane as separate musical voices from each of those chambers. So if I took a long time explaining that, compare that to what you're going to hear, because you're going to hear that rhythm right off the bat. You're going to hear the variation, the correlations right off the bat. And that's sort of one of the fun things we're exploring right now with accompanying graphical data with sound data, and using our kind of musical percepts to pick up on some of the patterns.
So just to build on that a little bit, the research here that's being sonified is a process of taking a cycle that normally lasts 24 hours, the day-night cycle, and bringing that down to a 6 hours experiment of a person walking through and checking various kinds of callers, they call them, I think.
Yeah, callers.
And then taking that experience and compressing it down to 3 minutes. And so that's an important aspect of climate communications.
So that's the next set. Light, and then dark. And she explained that she's going from the more liquid to the more dry end of that tram. So it does change, is kind of in a gradient. Yeah. And for my own purposes, this is a music I've never heard before. And you know, as just you know, a sound phenomenon, it's kind of intriguing. It has a rhythm to it, has a lot of built-in character, but it has this other message, which I think Greg will continue with now. So you get the idea, and
oh
yeah, it's good. It keeps going, and these are online. I can certainly provide URLs for them. Anyway, proud parent. She's just really methodical, I'll tell you. You know.
All right, so let's look what that looks like. So Native American Iñupiat High School in Barrow has an archaeology lab because the archaeologist is underfunded and figured that if the high school students can help her identify various samples and sort them, she'll get more coverage. What's happening is that a lot of archaeological sites are simply washing into the sea because of the permafrost melting. So you find maybe 3,000 years of human occupation and the archaeological record of that human occupation being washed into the sea on a daily basis. And this archaeologist is literally running around with buckets at the seashore, picking up bones, and I believe this here is the bone of a petrified bone of a dinosaur. It's really, really old, but there's other ones that are more recent and human artifacts and other elements that are more recent. While at the same time, the scientist is trying to capture gas that's coming out of the ground that's actually been carbon dated to be 3,000 years old. So the plant matter that's being processed and metabolized by the bacteria, by the microbes here, that plant matter is 3,000 years old. So the gas here has a signature of a 3,000-year-old creature. And there's a different way of handling that. And then, so the archaeological sites that are being washed into the sea, they can barely just collect it all and put it in bags and rapidly classify it by where it came from. But there's no time to study it. There's only time to just collect some of it. And of course, labeling is very important, and here we have the beginning of what Bruno Latour calls a circulating reference. So the scientist is actually in the field measuring something real, and then that measurement gets written down, the things get labeled, and as we go through this circulating reference, the situation becomes more and more abstract. And it is that increasing abstraction that is both necessary in order to put our arms around a wider range of knowledge than we can perceive directly, but also it removes us from the subject. And when I talked to Native Americans about this process, I said something to the effect that I'm admiring how well they managed to live off the land, and they laughed at me and said, "We don't live off the land. Look at this land. There's nothing here. Not even a tree comes forth. But yet the land brings us forth. The land is much larger than us. We're not thinking of the land as a subject. We're thinking of ourselves as the subject of the land." And that is a fundamentally different way of looking at environment and planet than we do. And in this labeling, we turn something into a subject. We say, okay, this gas was recorded collected at site 3A, and we're now going to analyze it, and we're making it into a thing. Making the Arctic into a thing also happens at the scale of oil, of course. In Barrow, there was an oil exploration for a while, but the results were inconclusive, and so the oil drilling probes became monuments, instant monuments in the downtown square. This is the big shopping center there, the Value Center, and that's the monument right in front of it. Here's a picture of science tools the syringes being discarded. It kind of looks like a flower, and I think it's beautiful. Another tool to manipulate and interact with the environment, the harpoon. This is a stone harpoon. This is this is one of the things that's found in the archaeological sites that can't be studied properly, just collected right now because there's too much of it falling apart. This is this harpoon tip, apparently, that was made out of stone. Here's a tourist attraction that also was made by the Iñupiat to entertain tourists, and the idea is that tourists always want to get into boats and into these seal boats and go rowing around in the Arctic, but apparently the kayaks. But apparently that's not a good idea because it's very dangerous. And so they made this photo op where you can put your head through a panel that looks like you're sitting in one of these seal boats and sealskin boats, and right behind it is the actual Arctic. And so that's one way of looking at the situation. And then the scientific way of looking at the situation can produce this kind of shape here. There are satellites, and those satellites maintain communications with this has a lot to do with military installations as well, maintain communications with home base stations, and it's exactly the opposite. The sensory device needs to be contained and packaged and protected from the elements instead of being connected to the elements. So it's the direct opposite of the previous one. There's whale bones all around town because the sharing, the collecting and sharing of whale meat is very important part of the community, and so they get exhibited there as trophies, and they're really quite huge and quite beautiful. A different kind of dome. There's no satellite in this one. The whale map from 1880 indicates where good whaling grounds are, and of course between the period of 1830 and 1880 there was a lot of whaling up in this area that brought a lot of white people into contact with the Iñupiat, and there was a lot of intermarriage, and that's why many Iñupiat have Western names such as Edwardsen or Nelson or so, and it's a whole period of history that was extremely exploitative and reduced the population of whales dramatically. The Iñupiat hunt 15 whales a year, and that seems to be in balance with the population, and 15 to 20 maybe whales in a year, and that seems to work. And they hunt them with this kind of thing. A sealskin boat is a picture of one that was recently put on the beach by members of the Brower family, and so you have their flag there, which is a cargo culture example. It's their flags are taken from the sailing alphabet, from the sails, from the flag alphabet that sailors used to use in the whaling period. And this boat here, you can see it's made of sealskin wrapped around wood, and it's not much. It maybe seats 5 people or so, and it's much smaller than the whale that they're trying to hunt with it. This is an inside look at the this kind of whaling boat. And you'd think they're Christian because they put a little cross there, but the relationship between Christianity and Native American beliefs is very complex. Still today, the pastors who are there, are active there, tell the Iñupiat that their traditional ways are devil worship, and that they have to, apologize and pray for forgiveness for their sins when they sing a traditional song. When I heard this, I was like, is this 2016? Is this the United States? Is this still possible? Absolutely, yes. So it's a very complex cargo culture where ideas get exchanged, and sometimes in very unfortunate ways. And so that burden of traditional knowledge being labeled as devil worship is still alive and well in this community. It's very troubling. A beautiful sight. So also the boat itself used to be built out of whale bones, but now it's being built out of wood, the driftwood mostly, or wood from shipping pallets that comes there, because there's no wood up in this area at all. Here's a sad picture of a graveyard in Barrow. So you see the ocean is right, that white line back there, that's the ice in the horizon, and the ocean is making incursions into the land, and the land is melting away, and this is a graveyard that's been there for 100 years, and it's just washing into the sea. And, you know, that's their daily picture. That's what you wake up to in the morning when you go for a walk. Mining is equally challenging. There's a lot of gravel that's being mined there because gravel is very important for the oil industry to build platforms on the permafrost there you can build houses on. And so gravel is a huge resource. It's a United States federal mining location for gravel, but the whole mining operation has itself begun to sink into the ground because of permafrost melting issues. And so that's not a very active site anymore. Here's our field scientist trying to collect all this and feeling very good after a 3-mile hike, the daily hike, to just go collect some samples. This is Ari Chafe, and she's going up there soon again, right? So this continues.
Oh, yeah.
Yeah, it's a lot of work to capture as much as possible. Here, we're going to take another look at the Edwardsen clan. Here's the Edwardsen clan flag, which is taken from the N, from the sailing alphabet. B, sailing alphabet B. And, no, it's N. I should know. It's N, and it's not for Edwardsen, it's for Nelson, which was the previous captain's last name. But it stays in the clan, the name changes sometimes. Here's and a very interesting contradiction when the Native Americans tried to figure out how to deal with land ownership, and they realized that there was oil and that the United States government was interested in taking over the oil-bearing parts of the land and nationalizing the lands. They had a choice. They had a choice. They could either fight the land takeover, the eminent domain land takeovers, and thereby abandon their traditional ways, which are very peace-oriented and very consensus-oriented. They could either fight and contradict their traditions, or they could not fight and stay with their traditional Native American Iñupiat way of dealing with challenges by being very accommodating and lose the land as a result. And so that contradiction was not leading to any good results, but until somebody, a Native American named Itok, and his friends had an idea to create the Ukpekiavik Iñupiat Corporation, and the corporation could fight for the land on behalf of the Native Americans. So it was like a device they could hold up in order to perform in a way they didn't want to perform themselves, but on their behalf. So it was a very interesting path out of a contradiction. And so this Ukpekiavik Corporation is very important, runs almost everything in the town. And so when you rent a car, you rent it from UIC, and when you rent a hotel room, you rent it from UIC as well. And most of their business, however, is in government services, in maintaining military bases around the world. And they got those contracts through relationships with the senator, Alaska senator. So this is their corporate ulu. You don't want to mess with that. This is the UIC CEO, the guy who was holding the flag earlier. Here he's in his corporate office. So the performance of holding the flag and the performance of sitting in the corporate office are very different. You see different aspects of the man. Anthony here and his lands vice president, Lars Nelson. And last few images here, we have a abandoned Quonset science lab, and it says on it, blocked from the inside. And when I saw that sign, I realized, wait a minute, that's exactly the challenge we're trying to deal with. That many of the things we ought to perceive, we can't perceive, not because they're not there, but because our own perceptual apparatus is too limited. We're blocked from the inside from allowing certain insights to become relevant for us. And so I was blocked from the inside because I couldn't see the Trump sign that was hanging on the door there for everybody to see. And maybe some other people are blocked from the inside in the sense that they don't have a choice but to live on the land that is changing so much, and to respond to the changes in whichever way they can. But to move for Native Americans in this case is not an option. And so what they're thinking of is building harbors that are floating harbors that allow for the Northwestern Passage for ships to come through Barrow again, or not again, but for the first time. And so they have great plans of building basically floating Native American islands that are essentially on artificial land. And maybe that's going to work. I hope it will. But all of these things we can only wrap our minds around if we are able to consider the problem beyond what is blocking us inside and beyond the immediate temporal framework. So here's a beautiful still of a flower growing. I thought we have to put in one positive image after all these dark images. Amazing vegetation growing in the tundra. It's one of the softest, most beautiful landscapes I've ever walked in. And that feeling of walking is almost like walking on a mattress, but the mattress is 8.8 million square miles. And you can just keep going on. And you can just lie down and it smells great and feels great. But it is definitely changing. So we're going to close. Our last element here is a brief video. I wonder, should we show it or should we take some questions? How are we doing with time? We have like 10 minutes left, right?
A little under 10 minutes.
Okay, so this one's 6 minutes. I'm going to show 3 minutes because I would like to hear if there's any questions, right? Sound good?
Yeah.
So I'm going to show a little bit of this. This is a project that's inspired by the visit to Alaska, and it's a collaboration with Chris Chafe again. Chris Chafe composed music that's based on a sample of. So first of all, do you know that the sun has a day? The day as in it rotates around its own axis. Every 27 days, the sun rotates around its own axis. That's interesting. And so what we did is we took one of the readings of radiation from the sun over a cycle of 27 days, because the radiation changes depending on which side of the sun is facing us and how many sun flares there are. And the reading we were looking at was from, I think it was from June 1st to June 27th. Is that right, Chris? Mm-hmm. And the data looked something like this. This was the radio flux intensity data. And then in the composition you're about to hear, we took this data and made this data be the speed of the music, okay? So the speed changes. It's slow, fast, slow, very fast, slow. But then the melody came from a threefold repetition of this same data. So you hear the same data 3 times, but at different speeds, which makes it feel very different. And at the same time on the video, you have the revolution of the sun around its own axis of 121 times over the past 9 years. So you're going to experience 3 time scales at the same time. And let's see what this looks like. It's the first time we show this anywhere, so. Oh, and this was performed live in Michigan as a carillon concert, so you're going to hear a lot of bells. And we don't have time for this right now, but there's an app where you can play along. So you could play the bells along with the performance. And that's what you hear here. You hear the carillons playing, but you can also hear some people with cell phones playing along. And this playing along effect is another time frame because not everybody hits the key at the right time. There. That was the first 3 minutes, and it's sometimes almost a little cacophonous, the whole thing. It's like, what the heck is going on? What a noise is this? But at the same time, there's these really beautiful structures of slowing down and accelerating that I hear in the music, and I really enjoy that. And there's another effect that you pointed out, Chris, which is that if we look at the sun like this, it becomes kind of like a ball that we can almost imagine holding in our hand. And then the sun becomes kind of a thing, which is the topic we started with. But the thing is still alive. It's not pinned to death. And if we can find this balance between holding something as a thing, but at the same time keeping it alive, so then it exists, and then we can really perceive what it's all about. And it's that subtle balance between objectification and compassion and really just living with it that I think would be the proper framework for mediation around climate change. Thank you very much. All right, so let's take a few questions maybe. And yes?
I was wondering if there was any living things, like plants or animals, that were dormant, or
that's an excellent question.
Have just come from somewhere else. The things that are now kind of coming alive there.
Well, there is a lot of migration of species about 100 miles north that we're observing, and there's various measures. Maybe you would know more, Sybil, about exactly what the rates are, but the species migrate about 100 miles north on a scale of about 10 years. Species also change their body parts, so there's this collection of honeybees that change this. If you look at them from 1870 to today, you can see in the last 40 years that the size of their tongue changed to accommodate for a broader feeding pattern. It's fascinating. So within a cycle of 40 years, the body parts literally change their size in animals. But what's really creepy is that in that tundra, frozen, are viruses that we haven't seen in 3,000 years, and they're coming out. So there's anthrax, there's botulism, and there's multiple viruses that have never been seen before, and it's not clear what they do. And so we may have all sorts of surprises there. So far, none of them have affected humans, but that's definitely a possibility. So yes, it's best to keep frozen things frozen, maybe, huh? Yes, any other questions? Go ahead.
I don't know if you're familiar with Nick Sauve's data sonification. He made turned data from forests into classical music.
Yes.
And I'm curious why you guys chose to use the sounds that you did and the instruments that you did.
That's a great question. We use the bells because the bells are a traditional alarm and sort of bringing people together kind of sound, and also because they have very interesting overtones where they resonate with each other in complex ways, and if you strike a bell just once, it produces many overtones. But Chris, you're the expert on this.
Yeah, well, sometimes when I get involved with data sets, I like to get just a sound quality that suggests what the data came from. First go at this ice core work, it's actually in conjunction with some geophysicists up in University of British Columbia. And one of them heard this first attempt and said, wow, it starts sounding like a boiling teapot at the end. I said, great.
That's what it is.
So, sometimes just looking for suggestive coupling between things. I work a lot with EEG and brainwaves, and I use the human voice for that because it's human data. So.
Yeah. Yes, and this is a growing field, and a lot of people are working with it right now, so we're very excited about it. Yeah. Any other questions? Yeah? Last one.
Do these native Eskimo, I don't know the word for it, but
Iñupiat.
do they know that Trump said that he got climate change was a hoax, and what do they think about it?
Well, it's a funny thing. I really don't know much about this, and I wouldn't want to speak for them. But when I worked in the Maldives as an artist to represent the Maldives in the Venice Biennale, there were some Maldivians who were climate change deniers, even as the water was literally coming over the sidewalk, and the logic of that is that wouldn't you rather it weren't the case in that situation? Wouldn't you rather wish that that wasn't what was happening? And there's a powerful thought in place there that is, if we accept it, we make it even more real. But if we deny it, we somehow distance ourselves from it. And the physical reality is not the same as the mental reality. And the question is, what produces a more actionable outcome for us? If we constantly think, oh, it's melting away, there's nothing left to do but to run away, then there's not much we can't, that doesn't put an actionable situation. But if we think, I got to go hunt a seal, and I got to go get out there somehow and figure out how to do that, different thoughts kick in, where thinking about climate change may not be the most effective thought. On the other hand, they do describe very subtly, and more subtly than most anyone I've ever spoken to, how the environment changes. They can tell you exactly what the temperature was on this day a year ago and whether it was warmer or colder. I couldn't tell you what the temperature was on December 9th, 2015, but a Native American in Barrow would be able to describe this and say, yeah, and the hunting was good over there and now it's good over here. So they're very much in tune with the changes, all the while not accepting maybe the fundamental considerations of climate change, because it's too abstract, but it's more concrete, the knowledge, right? Yeah. Good? One more? Good, one more.
Do you ever question the very notion of starting from data, the effectiveness of that idea of starting from data to produce media that will address climate change?
That's a great question, and absolutely we do. And we think that one medium is definitely not enough, and every piece of data has a bias and has a limitation, and sometimes just looking at the data makes you not look outside and look at what's happening right in front of you. So there's many other pictures that describe that, and many limitations. And I think the sonification actually makes the data a little bit less abstract and a little bit less absolute, because it becomes more associative, and maybe it actually opens up a sort of a looser coupling between insight and data, and not so much a tunnel version of looking at the data, nothing else. I think it's very important that we collect all these things and put them together, all these influences and put them together.
Greg
Let's talk more.
Explain to me the difficulty in making this moving images that show for 6 minutes in the Sun movie, that stitching together data seems to be a theme that we're encountering a lot.
Yeah. And it's a subject, not a problem.
Yeah,
right, that's
exactly.
right. That's a great point. Let's end on that and then wrap it up. So these pictures were taken over a period of 10 years, and in that time, the JPEG standard changed multiple times, and so we have pictures that are not going to go into the same video editor the same way. So we first have to, and I'm like, oh, why didn't NASA figure this out? Come on, people. And then I was thinking, no, the trouble of stitching this stuff together is producing is living with that question of what does the data actually mean, and is it just a representation, or is it a replacement for the real thing? And when you realize how fractured the record is, and struggle with that, you very much live the experience of its fragility and of its limitations. And the same thing with your 800,000 years, right? Yeah. That ice core sample was collected by multiple scientists in different ways, and so putting it all together is very hard. Yeah. Okay, one more thing. Did you all get the experience, the VR experience? Is it going around? Can you give some feedback to Christine and Akila about how it worked? How was the experience? Good? Applause? Boo? Applause? Okay, thank you. Thank you, guys. So maybe that's, VR is also something that takes our very perceptual apparatus out of the world of perception and hides our perceptions from others. And so it's a strange thing to go in there and look at data that way. But maybe the immersion opens something else. So all of these things need to be explored. Okay, thank you very much.